Yeah, we can start now. Wow. Yeah.
So the first question is that
This is for Excel.
to calculate the number of grade 12 students who should be in the sample, right? So do this. Does anyone wants to read the question first, or everyone did it? So I can going
Has anyone did the question? Guess not. Guess we can speed run it.
calculate the number of grade 12 student, right? So all we need to do is just look at the number of students in grade 12, and for this one it's 181, and then you'll use 181 divided by 740, and then you multiply the sample, and then you'll get like 6.115, which if you can get like half a student, you need to round it to the nearest, which in this case is 56 students. Sampling method, it would be quota and
It's we're supposed to look at, if you read closely to the question, it says proportion of the students from each grade in a sample is the same as the proportions in the school. So the more appropriate sampling technique would be stratified and quota, because stratified has like a certain like proportion that you need to fulfill, but you randomly sample it. For quota, like you need to place like a certain set of target that's proportional to the population, but it's not randomized. Yeah. Yeah, the session will be recorded. Huh?
really makes sense to me. Yeah, I don't understand it too, but they said for stratified, systematic, and simple random sample, each part of the population must have a proportion of being selected. But in here, I guess that's really weird. Like the mark scheme for this one is just
Okay, that's weird, but theoretically, since it's proportion, yeah, because quota in a way is like convenience sampling, but like you have a certain limit to it. Okay, next. Do you want me to read the question? Okay, at the end of the school day, the headmaster conducted a survey asking students in how many classes they had used the internet. The data is shown in the following table. State whether the data is discrete or continuous. Oh. Yeah, it's quite obvious. So because it's, yeah. So you multiply all of them and then add them all up. Add them all up. Yeah, and then that's the upper part. For the lower part, the sum of this. And then now you have two Ks, right? You can solve it algebraically, or you can just abuse your GDC to find K right away by using the solver if you want to. Yeah, the formula is in the booklet. Here. Okay, next. Mm-hmm. Right. I mean, if wait, this. Oh, the one we went through last night was not recorded, or the part. Yeah, because it was more of like a chill. Yeah, but I mean, we can go through it again if you want. It's pretty quick. Oh, okay. Actually, there's only just you. So like, do you want? They're not taking IP. Okay, okay. If you want to do HL stuff, let's just do HL right away. That's okay. Okay. The cars for Fairground Ride hold 4 people. They arrive at a platform for loading and unloading every 30 seconds. During the hour from 9 a.m., the arrival of people at the ride in any interval of 3 minutes can be modeled by Poisson distribution with a mean of 9t parentheses 0 is bigger than t. Wait, I don't know how to say that. So like t is like bigger than 0 and less than 60. When the 9 a.m. car leaves, there's no one in the queue to get on the ride. Shunshike arrives at 9:01 a.m. Okay, you don't know how to do this one. First, we need to identify what's going on. Like, if you don't know, sometimes the question can be like super confusing. Like, what the heck is this part, right? And to slowly go through it and digest it, you first try to identify like the thing that they're asking you, which is basically to read it. Well, one of the ways is to read out loud or to like underline all the stuff that's around. And we have Poisson distribution here when I read it, so that means you're going to have to use Poisson distribution. Well, actually, it's kind of a bit obvious if they say like loading, unloading every 30 seconds. That sounds like interval timing. So yeah, it's already hinting at it. Okay. Mm-mm. Yeah, and Oh wait, oh no, I can't undo. Yeah. So yeah. Like basically, if you have like interval of 30 seconds, and then they say that Shinsuke arrives at 9:01, so 1 minute. They try to ask the chance of 7 people arriving at the right before Shinsuke. So you want to find the average interval. I mean, like the Poisson distribution of people arriving, the number of people arriving in 1 minute. So the good thing about Poisson is that you can just employ at regular multiplication. It will work similarly. Yeah, see, so like for one, from 30 seconds to 1 minute, you just multiply by 2. So from 4 to 8. And then now they try to ask the probability that more than 7 people arrive. So that is the probability of x 7. More than 7 would be like equal to 8 or more, okay? Because remember, Poisson is discrete, so you can put in the Poisson CDF. Like, oh no, I can't type. Okay, so basically you can put in Poisson CDF for 7, and then 1 minus 7, which will get you 8 and above. That's the result. Next, the probability that there will be space for him on the car. So the car, is there a limit of the car? Oh, it can hold for 4 people. Wait a minute, this is 90. Oh wait, it holds 4 people. It's not the mean. Oh, so wait, 90. I feel like this. Wait, then I feel like this question would any t minutes. Yeah, so it's 9. So it's just x. Wait, what's that? X sim Poisson. Like, okay, I can't really type now. I don't know why. So it's when the mean equals 9, and then you just insert it right away. You don't need to do what I did just now. So they load and load every 30 seconds. That means that the mean of like the 901 car, the mean of people arriving at the 901 car. Oh wait, we also have to consider like the 9:30 a.m. car though. So this is like several probability. Okay. Hey, Lalambo, can you explain it? Because I can't really type, and that's kind of annoying. Guess all right. Is that okay? We try to break down the part B one by one. Okay, so 9 a.m. car leaves, no one in the queue, and then it loads and unloads every 30 seconds. Right. So that means that 9 a.m. car, bye bye. No waiting, and then there's a 9:30 a.m. car, so we have to consider that car. And then we also have the 9 minute 9 like the 30-second car, 30-second car, and then we also have to consider the 1 minute car. This is when Shinsuke would arrive, right? And when we would need to see if 1 second, 60 seconds, then yeah. So the Poisson distribution has the mean of 90. That means every 3 seconds, 4 people. I think the simple way to answer, I'm not sure if it's correct from the mark scheme. Oh god, why is it? I'm so sorry, guys. I don't know what's going on with this thing. Simple way to do it would be x sim yo 9, like 1 minute, and try to find the op. No, actually, this is the more complicated version because it has a bigger value. Never mind. So we need to find this, and then we need to find this. So if we have every 30 seconds, that means we need to insert the time as half, right? Since it's, yeah, so the Poisson would be, that's correct, the Poisson distribution would be like 4.5. That means you're gonna have to consider like different combinations of this thing. The possible combinations that would work would be if the Poisson distribution is like total maximum is 7. So it could be the probability combination of x PO when the probability, the first probability range would be from 0 to 7. Yeah. Then why is the mark scheme mark so big? Like, I thought it would be the complicated version. And consider, I, I feel disappointed. Okay. Huh? X more than 7? Are you sure? Wait, that's for 16. Yeah, 16A. How about B? Yeah, then what I'm doing is correct. No. Then what I'm doing is correct then. Yeah. 16B is when t equals to 30 seconds. So, yeah, the first version, like the first second would obviously be from 0 to 7. The probability when it's from 0 to 7 passengers. And then the second would also be from the range of 0 to 7, depending on what you get for the first answer. So, so like if you have the first probability as if you have the first probability as 0, then the next probability would be 7. So 0.3.0 times probability when it gets 7 plus, probability when it's 1 times probability when it's 6, and etc., etc. And it goes on till you get the probability when it is 7 times the probability when it's 0. Does that make sense? Yeah? So like, I guess you can just lump them together. So, in a like Poisson distribution, like this 4.5 distribution, there's a range of values that you can get, right? But the probability of getting it is different. However, like the mean average of getting it would be 4.5, and the variance is also 4.5. So the question is asking, find the probability if there's space for Shunsuke when he arrives. So the car holds 4 people, and it goes every 30 seconds, right? So for each car you have 4. And like, yeah, okay. So you have to add up all these probabilities, and that would be like 2 times 0, probability of 0 times 7, probability of 1 times probability of 6, probability of 2 times probability of 5, and probability of 3 times probability of 4. You can just like condense it and multiply by 2 because it's going to be the same reverse kind of thing going on. So you can insert that to your calculator, and I hope that gets you the correct answer. This is basically like, if you think about it, it's like approaching Poisson distribution, but also with probabilities, like the possible choices of getting the answer. I'm not sure if there's like a simpler way of doing it, but that's just like how I would approach it to the knowledge that I'm given and know. Okay, Lala will have the mark scheme. I don't really have it, so she can share it to you later. Try to look for like the Poisson distribution in my calculator. Did I get it correctly? Oh, it doesn't Oh, you don't multiply it by 2, but close enough. Wait, why not multiply it by 2? Well, either way, like, I hope you guys get like the basic concept of it. Yeah. Okay, next we have what a question. Great. Okay, next we have, this is more Poisson distribution. The number of hornets arriving at the nest follows the Poisson distribution with a mean of 2.1 hornets per minute. So this time the sign would be x times Poisson. Yeah, I can type again. Never mind, I can't. Oh, okay. Wait, did I just skip some? Oh no, did I just deleted the question? Oh yeah, just deleted some question. Okay. You know what? I'll have to do that again. 2.1 hornets per minute. Find the probability that fewer than 12 hornets arrive in 5 minutes. This is 2.1 times. Yeah, that's correct. In oh, okay. Okay. This is just the first one is just GD's calculator abuse. I'll just run it since this is per minute. This is going to be the number in the the Poisson sign. 2.1, and then because this is 5 minutes, remember the multiplication way, like you just multiply the 2.1 by 5, so that would be 10.5, and then 12, you just input this, and 11 in a GDC, it's 11 because remember that Poisson is discrete and they're asking for fewer than 12, so 12 is not included. Okay. Then find the probability that more than 10 hornets arrive in 5 minutes. This time it's like similar to the one before, but it's the opposite. So more than 10 would be from 11 and above. So for this time, since the probability for, what is that? The calculator goes from left to right. That means you have to insert 10 and then minus the result by 1. And that would give you the final result. Okay, the next, find the probability that fewer than 12 hornets arrive, given that more than 10 hornets arrive in 5 minutes. So this is like, try to think of this as like probability sense. So given that more than 10 hornets, which is B, the probability of more than 10, they're trying to look for fewer than 12. So they're trying to look for between more than 10, that would be 11. And fewer, wait, that's probability of 11 hornets only though. So it's just probability of 11 over probability of more than 10. That would be your final result. Yeah, that's pretty much it for this question. Okay, next we have the standard deviation, unbiased standard deviation. Manager wishes to check the mean weight of flour put into bags in this factory. He randomly samples 10 bags and finds a mean weight 1.478 kilogram, and the standard deviation of the sample is 0.0196. So find the unbiased sample, the unbiased standard deviation of the sample. So we have standard deviation is this 0.0196, 0.196. And you have to remember that, actually you don't have to remember, just check your formula book and you would know that the formula is 0.0, like the standard deviation, times the square root of n over n minus 1. So that would be 0, no, not 0, sorry, 10. The n would be 10. You just insert 10 in these and then insert it in the formula, and that would give you the final result. And okay, so yay, that's the final result. Okay. For 95% confidence interval for the population mean, giving your answer to 4 significant figures. Yeah, okay, so you use the t interval because they don't say that it's like normally distributed, and it gives you the sample standard deviation. So the key for like determining if it's C or T interval is the standard deviation, or whether it says it's normally distributed or not. And okay, so for like, if you've seen mark schemes like Revision Village or something like that, you see that they try to work on it manually, but you don't really need to know how to work on it manually. You can just like and click on your GDC for like the interval and find the, yeah, you can just click on the GDC and then click, and then that will give you the final answer. Where do you learn how to use GDC for all of this? I mean, I can't really teach you that because each GDC has their own way of working on it. Like personally, I use Casio GDC, so I would be able to teach you for Casios, but for like other stuff, you would need to Google it. So like, just Google the name of what you're doing, like confidence interval. Just Google confidence interval GDC name. Usually, most of the time, the YouTube videos that pop up would explain to you clearly. There's also the calculator manual if you want to bother reading into that. But it's a bit confusing sometimes if you're not used to reading like those kind of manuals. Yeah. But I can help you if you have a if you have a Casio GDC. Oh, so great! I can help you if you have any questions about it. For Casio, do you want me to just go through it really quickly? So for Casio, you know the stat main menu, right? Yeah. After you go into the stat menu, there's several of those like window menus on top, the F1, F2, F3, F4, F5, F6. So there's this thing called INTR. It just basically means interval. You click on that, there's a Z and T interval, and that's like where you get the intervals. Most of the time you only use the one sample one, and then you insert similarly, but this time you have the C level confidence interval, your mean, your standard deviation, and your number of samples. So yeah, that's where you find it. Next, the bags are labeled as being 1.5 kilogram weight. Comment on this claim with reference to answer in part B. So this would depend on the answer of like this before, whether if it's like outside the confidence interval or inside the confidence interval range. So if it's this is like I usually call it as like indirect hypothesis testing. So if you have if it turns out that this result is outside the confidence interval, so like let's just say like this, you have the confidence interval values, the thing that will be given on your calculator. If your result is outside, that means that it's not the safe number to be considered as the mean rate of the flow. So you would say like the mean weight of the floor is, if it's inside, you can say that the mean weight of the floor is in the population range. Like it doesn't reject the null hypothesis. If it's outside, then it's too significant to be considered as the mean weight of the floor. Okay, next. Does Lalama want to add up on anything? Do you want to work on this one now? Yeah.
Sure. I mean, we already covered it yesterday, but we can do it again. So,
Oh yeah, we covered this one yesterday.
we can do it again. So basically, this is just written down the distribution. The mean is A5 and the standard deviation is 0.5. Set up the probability is greater than that. This is a normal distribution on this distribution. Just need to do it.
So you use the norm CDF this time. Oh yeah, remember that like some CDFs would go from left to right. So this is asking like 90 and above this area. So if you have like the one that goes from left to right only, then make sure that you input 90 and then minus 1. Like 1 minus the probability value. NPD and NCD. Yeah, NCD. So for Casio, it's usually called CD, PD. For I think most other calculators they call it CDF, PDF. Yeah, and Roxas is correct. Normal distribution is in continuous form, not in discrete form. How does the inverse function of this work? Okay, we don't really have a question on inverse right now for this one. So for the inverse function, you like graph. You have the, yeah, let's just like have a question about that later on and we can cover that. Yeah. Okay, next, we want to know, you have 2 samples this time in different orchards. It wants to know whether the mean weight of this one is greater than the mean weight of the second one. So this is comparing between 2 samples. Whenever you compare between 2 samples, you always use a t-test. Because yeah, that's like the only if it's 2 sample t-test, because it's like the only thing with 2 samples. Yeah, but usually that's like only 1 sample. So you just insert these numbers on the spreadsheet, and then go to the t-test 2 sample, and use the list to represent like your data, your 2 datas, and make sure that it's in order. So like if you do this first, if you input this first in the first column and then this is the second column, that means that the setting in your calculator should be the first mean is greater than the second mean. So the p-value would be, last time we calculated it was less than 0.05. Because, yeah. Nice. Next, state the conclusion of the test. So, since the result doesn't exceed the 5% significance level, that means that it can't reject the null hypothesis. It can reject the null hypothesis. So that means that we can reject the claim that the mean weight of the apples and the mean weight of the first apple tree and the second apple tree is the same. So that means that we can accept the statement, the owner of the orchard statement. Yeah. And also state if it rejects ours, do not reject the null hypothesis. Okay, next. The data has collected some data regarding the heights of h meters of waves against up higher at 50 randomly chosen times in a single day. This data is shown in the table below. Height, frequency. She wishes to perform a chi-square test at the 5% significance level to see if the height of waves could be modeled by a normal distribution. Her null hypothesis is that the data can be modeled by a normal distribution. From the table, she calculates the mean of the heights in the sample to be 0.828 meters and the standard deviation of the heights to be 0.257 meters. Use the given value Sn to find the value of Sn minus 1. So you need to find an unbiased sample. So we've gone through that before, right? Okay, this time, yeah. I want you guys to try to calculate it. With the formula, yep. Okay, so that's correct. Then she calculates the expected value, each interval under this null hypothesis, and some of these values, this is, okay, other than the A part, the rest of this is, I think, also for SL. Because they let you find the frequency right away. So, for chi-square test, remember that you're going to have two values. The first table is the observed outcome, and then the second is the expected frequency. Usually this is written as O and E. And find the value of A and the value of B, giving answers correct to one decimal place. Oh, so you're supposed to find the value of these two using the normal distribution thingy. That'd be easy. You just input it in your GDC. Okay. 7.8. And 8 to 8 for mean, and for standard deviation it's 0.257. The version, the unbiased version, that would give you 0. Oh yeah, and then you multiply it by okay, yeah, then you multiply the value by like 50. I'm gonna assume that's correct because Lambo has the mark scheme and I don't have the mark scheme. Okay, next, find the value of x chi-square statistic for the test. So now you have, yeah, now you finally can insert it here and then run the chi-square test. This time you have to run the chi-square goodness of fit, or GOF. Get it? Goodness of it for distribution. So this time you just like click on your calculator and then input test chi-squared goodness of it. Input the numbers, and you also need to input the degrees of freedom. So this time you have 50 participants, and the degrees of freedom is the number of participants minus 1. So that would be 49. Inserting them all, that would give you a final answer. Two per. Oh, two per minus 2. Oh, okay. Minus 2. So that would be 48. It's usually like minus 1 or minus 2.
So we combine this all together because it's less than 5 in like
Oh, because oh, okay. So basically, something that you need to pay attention in chi-squared that I also forgot. Thank you for the reminder. The expected values needs to be above 5. So this is not really something that's tested in SL, but it will be tested in HL. You're expected to know about this and merge it by yourself. If you have data that are whose expected values are less than 5, you need to merge both of them. So the last cell would be 3.6 plus 3.8. Oh yeah, so the upper part is also going to be merged together. So this would be 6. This would be 7.4. So you insert all the data, including this one, and then it has 1, 2, 3, 4, 5, 6, 7, 8. So since it has 8 columns, you need to, it's minus 1. The degrees of freedom is the columns minus 1, so that would be like k minus 1. That would be the more appropriate term for it. So this time it would be 7 then, yeah. So inputting your calculator gives you 5. This two. Okay. I got the p-value of 0.787. And okay, so this is where a critical value also comes in play this time, because they ask true the critical value. So if the chi-square test, like, how do you call it? The shape of the distribution is kind of like something like this. I don't know how it exactly looks like. Like, it changes depending on the degrees of freedom, but like it's kind of like a skewed-ish distribution looking kind of shape. So let's just say this is the shape of it, an estimate of it. It has a critical value of 9.49. The value that we got right here, or at least what I got in my calculator, is 3.93, so somewhere here. So in order for you to reject the null hypothesis, it needs to exceed the critical value. However, it didn't exceed the critical value. We got 3.93. That means that we can't reject the null hypothesis, and therefore we would need to accept the fact that the data can be modeled. So we cannot deny that the data can be modeled by a normal distribution. You can never say to accept it, because the point of like the statistical test is to falsify this statement. So like to say that you cannot deny it or you cannot falsify the statement or the null hypothesis, that would give you the correct answer, the correct conclusion. Okay. Should we go to the next question? All right. Another Poisson distribution. Oh, with the type 1 and type 2 error. The number of fish that can be caught in 1 hour from a particular lake can be modeled by a Poisson distribution. The owner of the lake, Emily, states that in her advertising that the average number of fish caught in an hour is 3. Tom, a keen fisherman, is not convinced and thinks it is less than 3. He decides to set up the following test. Tom will fish 1 hour, and if he catches fewer than 2 of the fish, he will reject Emily's claim. Okay, so basically in this circumstance, they have a hypothesis test in a way, like indirectly, but you don't set it up-ish in a way like the normal distribution way, but they will usually inform you what is like the threshold of getting rejected, the threshold of rejecting the null hypothesis. And in here, it's when he catches fewer than 2 of the fish. So now you have to state the null and alternative hypothesis for Tom's test. So that would be HO when it equals to three And for the alternative, it would be h1, equals to mean as the tree. The second would be the alternative when the mean is less than 3. So it would be like this. And it would be significant enough to be, this statement would be significant enough to be accepted, like you would have significant evidence to reject this claim if Tom catches 2 fish. Fewer than 2, so fewer than 2 would be 1 fish. Right, because this is Poisson and it's supposed to be discrete. So, find the probability of type 1 error. Type 1 error is false positive. That means when you caught let 1 or less than 1 fish, like exactly 1 or less than 1. However, it's actually more than that. So that would be, you just need to find like the probability of catching 1 fish or 0 fish. So like you just insert it into the Poisson distribution, like Poisson CDF, and 1, 3. That would give you it's probably, yeah, the probability of rejecting it when it's true. Yeah. And the answer be 0.199. Okay. Lalambu, can you confirm if the answer is 0.199? Yeah, see, yeah. So it's just, the funny thing about this part is that, like, when they ask you for a type 1, it's just really asking you the probability when it's like 0, when you get 0 fish or 1 fish. Like both of them. And then now we were told that the average is actually 2.5. So this time you have to use like this condition when Poisson, like the average mean is 2.5. And they're asking for false negative. So that means when they say that false positive, false negative. So that when they said that it's like it's not significant when it's actually significant. So that would really just be like the probability when it's more than 2 fishes. So that would be like using the same Poisson distribution, the Poisson CD. You put in 1 and then you minus the result by 1, so that would be 0.712. I think that should be correct. Yeah, it's kind of weird, but like Poisson distributions type 1 and type 2 kind of works differently from the usual normal distribution stuff. Ah, I see. This is just for Poisson. For a normal, oh, okay, for like the type 1, type 2 thingy. The cat, the cat emoji is tripping me off. Next, we have transition matrices. Two taxi firms, Alpha Cabs and Beta Cars, are well established in the market and have market shares of 50% and 40% respectively. A new company, Gamma Carriages, has recently entered the market and has market share of 10%. Given the monthly transition matrices, the transition matrix ABG, find the likely steady state market shares of the three taxi operators. Find the like oh okay. So they want to look for they have these market shares, right? Yeah. A steady state of the market share. So they're trying to look the long term of these values. What happens if you repeat it again and again and at some point it will converge to like a certain amount. So the easy way to do this is just to like transition matrix T to the power of 50 times the market share in order of ABG following this. So that would be 50, 40, and 10. And then you use your calculator to look for it. Oh, there's a syntax. Okay, so if you input it into the calculator, 0.85, 0.05, 0.1, 0.05, 0.8, 0.1, 0.1, 0.15, 0.8 times the 50, 40, and 10. So that's percent, right? Make sure, remember that it's percent. 50, 40, 10. Long term of it would equal to long number of it would equal to 30. It's supposed to be two. How do you call it? Two black backslashes. So yeah, I got the same result as that. Yeah, it would be fine if you put it as a percentage because that's like the initial version of it. the original version that we were given with. Oops, I made a mistake with the code. Okay, that should give you the correct answer in terms of latex. And next, find the likely steady state share by setting out system of equations. So, like the one I explained yesterday, basically you try to find the long term of it, and it will turn into like the same value throughout. If you multiply it like by a certain number, it will result in the same number. That's what you're trying to look for. So xyz equals to xyz. You can, if you learned about matrices before, you know that you can turn this into a system of linear equations. So like 85x, 0.05x, 0.1x, xyz, xyz, x, y, z, they're all like added up. X plus 0.50y plus 8z equals to, yeah, thank you. That is a lot better written than what I'm doing right now. And then remember that a special property is that since like these are all probabilities, they add up to 1. All of these. So x plus y plus z equals to 1. And from there, you can insert them into like the system of linear equations. Yeah. And you can just discard like one of the linear equations that you have right there, because you have 3, right, from the matrices. Just insert 2 of them and then add up the last one in the simultaneous equations, and that would give you your results. Solve. I mean, that gives you, honestly, that gives you pretty much like the same result as the initial one. Yeah. Yeah, it's just like, you can say it's 2 different ways for you to look for it. However, like for the second one, it applies if you don't have the different shares. So you have to use algebra. Okay. Next we have this question. Oh, this is the, okay. For the last one, your probabilities were very small. Is it? Oh, is it for this question? Oh, okay, so let's go through it. Do you want to go through it, or are you just going to send like photos from? Okay.
Basically, for let me read the question. So as Japanese sushi two species of tuna from a single supplier, yellowfin tuna and bluefin tuna. The weight of these two tuna species are usual and are normally distributed. Distribution. So this one is combination and transformation.
Wait, the first question is not. What the probability do not leave?
less than 2 times the weight of the yolk. To make it more simple, I would recommend you guys moving it to moving one side and the other side being 0. So the way I would do it would be b minus 2y is less than 0. So in this case, my x would be b 2.
Yeah.
Okay, so and then you need to find the expected value. So the expected value, you just basically add everything. You just follow the equation.
Yeah, you follow, yeah, the. Yeah.
And keeping in mind that this time is like multiplying 1. As I mentioned earlier yesterday, so it is e to the power of 2.
Yep.
Get it? And then you just enter it into the calculator. Probability of x being less than 0. And you would get that. And also like draw a diagram just in case you need it. And for the another question, it is like a blue tuna, and 2 yellowfish tunas are selected. So this one you have like 2 yellowfish. So the way I would write it would be and then just like the earlier question, you just
Wait, 25. Ah, okay. I wasn't calculating, so I have no idea what's going on.
I did it yesterday, so I was wrong. So, yeah, maybe my answer might be correct because I didn't look at the mark scheme for this one, but the overall the logic works this way. I'm so sorry. Yeah, if I'm wrong, yeah, please tell me. It's like I can also know my mistake. Yeah.
I mean,
And then
I just made several mistakes before.
yeah, so and so for the question B, it's just like last time. So x would be equal to b minus y. So the expected value would be exactly the same. However, for this one, the variance would be lesser.
So, b minus y3.
You would get like 43. You have like 2 yellowfish and like and when you multiply the weight of only one fish. And then you just do it like
Yay!
in case you get anything wrong. But this is the overall logic of how this type of question works.
Now we're back to SL. Where's SL section? Okay, here. I did this one. Also this one. This one too last week. Oh wait, okay. Yeah, no problem with it. Okay, now we have this. Yeah, Palfinder breeds Labrador puppies at his farm. Over many years, he recorded the weight gram of the puppies. The data is illustrated in the following box and skid diagram. Weight of Labrador puppies G. Write down the median weight of the puppies. So it's this one is self-explanatory, right? Like yeah, the median is just like you. Oh, okay. This question is too easy. Except for the outlier. I would feel like the outlier is the one that's tripping people off, but it did. Yeah, we also did this one yesterday. It's just Pearson and Spearman. I think we have another one like in the next question. Yeah, see, we have another one in this question. Teachers concerned about the amount of lesson time lost by 8 students. True. Oh, the formula of the outlier is okay. Let's just work on this one then. This is 210. Upper is 240. And then the lower part is 190, right? So the interquartile range is upper minus lower, the range of the spread. 240 minus 190 is equal to 50. Okay, so that is the IQR. And to find the outlier, it's basically Q1 minus IQR times 1.5. And then the second is Q3 plus IQR times 1.5. Okay, I can type, that's good. So that would be 190 minus 50 times 1.5. That would be 115. And then, so that's like somewhere, somewhere here. So some of these values you can see is an outlier. And then the second is 240 plus 50 times 1.5. Oh, my typing broke again. They'll give you 315. And oh, I accidentally deleted the slide. Okay, 315 is way beyond the range. So there's no outliers here. So the outlier section is here. Outlier section is from 100 to 115. The weight of the heaviest possible puppy that is not an outlier. So since you're asking for the heaviest possible weight that is not an outlier and none of these point past the outlier area, that means that the heaviest puppy that is not an outlier is 290 grams. Yeah, okay. Next question. Then, oh wait, this is the one we've just done yesterday. Teacher is concerned about the amount of lesson time lost by 8 students who are arriving late at school. Over a period of 2 weeks, he records the total number of minutes they are late. He also asks them how far they live from school. The results are shown in the table below. Find a point correlation coefficient from the data. So you just insert this and you'll put in the scatter plot graph and then click on the line of best fit, and that would give you the Pearson product moment correlation. Further research indicates to the teacher that for data similar to his data, the strength of the correlation can be set according to the following table. Comment on the strength of the correlation corresponding to the value of R in A. So remember that, like, to report the R value, you must add the strength. You must add the description of how strong it is and whether it's a negative or positive correlation. And I would need to insert the values one by one for this. Oh yeah, and next. Okay. I'm going to assign the answers for this part. Okay, so the p-value is 0.661. That means it's moderate positive. And then, yeah, for the Spearman correlation, correlation coefficient, if they ask you to look for it, then you need to make a table where you rank the data. So don't worry about drawing a table when you encounter the question. Which of the correlation coefficient would you recommend to use to assess whether or not there is an association between the total number of minutes late and distance from school? Just fully justify your answer. So, it depends on the strength of the correlation. Does it or does it not? Okay, so wait, sorry, I skipped the question, which is to comment on the strength of the correlation. So to comment on the strength, you can comment it similarly like Pearson, but add the word monotonic in it. I don't know why the mark scheme doesn't ask you to add the word monotonic, but it's crucial to add the word monotonic because basically it tells you that the correlation is increasing in value. Yeah, so there's a difference in the interpretation of Spearman's and Pearson. For Pearson, it's about how spread out the data is from the line. For Spearman's, it's actually more of if the data is in increasing order. I don't know why it's okay. I really don't know why the mark scheme never asked for monotonic, but that was like what I know. Yeah, so it's just in case, just include it. Okay. So like if you have a graph that looks like an exponential graph, like a scatter plot that looks exponential, and the points are like perfectly exponential, the Pearson correlation would think that it's a data with like moderate or bad spread. So like let's just say around 0.6 as the correlation value. But for Spearman's, it's going to say 1 because it's measuring like the order of the values. Like this. Order in increasing value. So it can consider a graph that's like wobbly. As long as it's constantly increasing, it would be 1. Yeah, so that's why. And the term monotonic is basically like this, referring to the fact that it's increasing constantly. The total number of minutes late and distance from school. Okay. Other than that, yeah, Spearman's is also good with outliers. So like if you have something like this, and then you have like let's just say this is a straight line, and then you have like a big random outlier very far away right here. The Pearson's gonna think that, oh, your data point is like very spread out. But Spearman is going to be like, oh, it's just that one outlier. So the strength of the correlation is going to be bigger in Spearman's than in Pearson's. And like if if you compare the two, you can, and look at the graph, you can figure that out. Okay, next we have a question of probability. Sweets are produced such as 80% are star-shaped, and 20% are shaped like a crescent moon. It is known that 10% of the stars and 30% are colored yellow. 30 of the crescent ones. So you need to copy and complete the following information. So remember that probability totals to total probability is equal to 1. And then in the case of like, yeah, always add up to 1. That's correct. And in the case of this, it's kind of like after this event, you have two choices for its probability. So for every tree branch, they total up to 1. So if this is 0.10, 0.1, then this would be 0.9. And then this is 30 is yellow, right? So 0.3, 0.7. Okay, so usually this, like if you multiply the values here and put it here, multiply values, put it here, multiply here, multiply, put it here, the total of this value of all these probabilities would equal to 1. The sweet selected at random find probability that the sweet is yellow. So they want to find yellow and yellow. So you just multiply these and that would give you the result. Like and add them both up. Yeah, and you get 0.14. Given that the sweet is yellow, find the probability that it is star-shaped. So this is like in the condition of yellow. So when you have this and this condition, you want to find when it is star-shaped. So between when you have like the choice of both this and this, like total probability is 1. Like if you always get yellow, then what is the chance of getting a star shape when it's yellow? So in order to do this, yeah, the properly written way is to, the lower part would be the probability that the sweet is yellow. And then the upper part is the probability when it is star shaped and when it's yellow. So I don't know. Wait, actually that's a fast one. Oh, okay, she got it. 0.571. Yeah. Alternatively, you can think of this as like a Venn diagram. Like, okay, so let's say this is sweets, like the type of, this is, yeah, this is like star shape, and then the other side is crescent. And then this is the yellow shape, yellow or not yellow. So, like, it's like saying that if you're considering this area, what is the chance of getting this part? If that makes sense visually. Oh, then now we have, yeah, that formula is in the data book. It can be found in the data book, but sometimes it's like, if you don't understand like how do you say the symbols, then it gets confusing and you can't use it. Okay, Jay, he plays a game involving a biased 6-sided die. The face of die are labeled -3, 1, 0, 2, 1, 0, 1, 2, 5. The score for the game X is the number which lands face up after the die is rolled. The following table scores shows the probability distribution for X. Score. So we need to find the exact value of P. So you can use, we call the two like, I hate those ones when there's more than one physical value. Like, it's, I mean, for me, it's not that bad. Like, do you want to do it?
Yeah, sure. So basically everything needs to be equal to 18, right? So all you have to do is just 1 plus 3 plus 3 plus 1 plus 2 plus 7 equal to 18. And you just yeah.
Yeah. Yeah, and that will give you P.
To find the expected score, you just multiply the score X with the probability, and then add for the negative 3, and then add for the one with negative 1, and just add it all together.
Multiply them all, and then
Multiply them all. And
add them all.
Yeah. And you will get 1.83.
Yeah. The fun part is this part. Twice and add two scores together. So for a probability that he has a total of 3.
One combination would be negative 3 and 0.
Yeah, that's literally the only combination you can get. So, yeah, that's just 1 over 8 times 3 over 18. 1 over 18. Yeah.
They place the game twice, you also need to multiply.
Because, okay, so it's kind of like, it's a total score, right? You need to find the combinations of when you do roll the dice 2 times, you get minus 3. Like, something score, something plus something score equals to minus 3. You need to find the possible combinations of this. And for here, it's only 0 and minus 3. Yeah, that's alright. So it's only this and this. Yeah. And then you multiply it by 2. Because there's either minus 3 first and then 0, or 0 then minus 3. Do we need to multiply it by 2? I feel like you don't, because the question that before doesn't, and usually for, I wish the exam comes like this, which is for so. Yeah, I mean, who knows, there's something similar to this question. Mr. Burkett teaches a mathematics class with 15 students. In this class, there are 6 female students and 9 female students. Randomly chooses one to answer a homework question. Find a probability that any given day, Mr. Burkett chooses a female student to answer the question. So that's just easy. 6 over 15. Because they're just asking out of total 15 students, he randomly picked one, and it has to be female, and there are 6 females, so the chance of getting picked is 6 over 15. In the first month, he teach 10 times. Ooh, okay, so, okay, recall, in binomial distribution, you have 2 possible choices, right? Yeah, 2 possible choices, and in this circumstance, you can apply it, because you have the same amount of students, same amount of females and males. That means that the probability of getting a female, 6 over 15, 1 minus 6 over 15 would be the probability of the males. in binomial, you do the trial several times. So, yeah. Probability of choosing. So now you put it in your calculator, the probability of F. Wait, probability of F? Okay, sorry. You, for B, you put in the probability that it will, what? You just had to. Wow, okay. Yeah, okay. Wait, I haven't even calculated it. Yeah. First one, second is binom CF. Yep, that's correct. Okay, like I mean, it's just calculator insert, so we can proceed. As long as you guys understood what happened. In a coffee shop, the time it takes to serve a customer can be modeled by a normal distribution with a mean of 1.5 minutes and standard deviation of 0.4 minutes. Two customers enter the shop together. They are served one at a time. Find the probability that the total time taken to serve both customers will be less than 4 minutes. Clearly state any assumptions you have made. Okay, so you need to find first the probability and then the assumptions. State the assumptions you make. Um, the probability that will take be less than 4 minutes. That means that you have to consider two customer. Which one do we use? Poisson. There was a lot of Poisson questions before. You kind of missed it, but it's okay. Yeah, this clearly states normal distribution. So if it states normal distribution, then it's normal distribution. You can't try to bend it or try to like, yeah, it's definitely normal. Maybe less than 4 minutes. So that means you have to transform the normal distribution into like two people. Like, so the normal expected value will be multiplied by 2 times 2 equals to 3. And then the standard deviation, we need to transform the standard deviation into variance first. So 0.4, wait, I'm gonna put it in calculator. Yeah, 0.4 to the power of 2 would equal to 0.16. And then now you multiply this by 2 to the power of 2. And that would give you 0.64. And then since this is in variance form, you have to turn it back to standard deviation because most calculators use standard deviation, and that would give you 0.08. Wait, oh wait, 0.8. My bad. Wow, the use of calculator has messed up my thoughts. Oh wait, I mean that also works, I think. Like, does that give you the same answer? Oh, it gives you a different answer. Oh wait, we have to what? Wait. you have to variance, you have to square root it. But that gives you like a completely different answer from like what I got. Maybe I messed up the calculation for it. Did I mess it up? Huh? I'm trying to like recalculate. Huh? I'm trying to do the standard deviation, but I got a different like answer from yours, like from a different approach. Yeah, so you add it up, right? I multiplied by 2. And I mean that's why like if I yeah so okay, so for times 2 I get that that makes sense, but like for times 2 you're supposed to multiply the standard deviation. You're supposed to square the standard deviation, right? And then after you square the standard deviation, you multiply it by 2 to the power of 2.
No, you don't do it 2 to the power of 2. Because it's, for this one, it's like,
Oh.
they have 2 different students. Unlike the earlier one where you have only 1 customer and you multiply by 2, this one you have like 2 customers.
Yeah, but I was thinking like if you multiply the standard deviation by 2 instead of adding them, that would also work similar. That would also give you the same answer. Oh, that means wait, you're not supposed to square the multiply by 2 part.
Yeah, I didn't multiply.
Oh, you know what? Let's just go with like plus 0. Yeah, let's just go with 0.4 squared plus 0.4 squared. Ah, for some reason I thought it's like 2 squared because it's when you move it out, it's like the multiplication is squared, right? Or did I remember that wrongly? Okay. Oh, this is the case of. Oh. Yeah, okay. Okay, well, then yeah, the answer is like 0.5 something something then. 5656. Yeah. So now you can find the one that's less than 4 minutes. You just like try put in norm CDF. The value range of norm CDF that is 4, because this is continuous. It's 4. So that gives you the, yeah. Oh, wait, normal is always CDF. No, for this one, it's supposed to be CDF because it's, trying to find, okay, yeah, makes sense. It's always CDF because, okay, so yeah, lower would work with like -1 E99, or you can just put in -99. I usually put in 1 times 10 to the power of 99. It's the same thing. Basically, you just need to put in a big number. Yeah. Upper. the mean is 3. Don't forget to not use the original mean. And lower is not 0. Lower should be time is not negative, but normal distributions can be negative. Normal distribution works differently. Because normal distribution is like a probability distribution curve. So like let's just say like 4 minutes is around here. Wait, actually 4 minutes is okay. If it's like 3 minutes here, and 4 minutes is a lot. So you need to try to find the probability of anything that's lower than 4. So all of the probability distribution like area, and to like make it so that the like it's already in the stage where it's infinitely small that it doesn't matter, you need to put in a super big number like minus 999. Okay. As a okay, so does that make sense? I hope that does. As part of a study into healthy lifestyles, Jing visited Surrey Hills University. Jing recorded a person's position in the university and how frequently they ate a salad. Results are shown in the table. Jing conducted a chi-square test independence at a 5% level of significance. State the null hypothesis. So, oh yeah, Lambo, do you also want to do this one?
Yeah, sure, I can do it. So
Okay.
the null for chi-square test for independence is always x and y is even. So for in this case, it will be because the profession in university and half the family they ate salad is independent. And then for D, when you need to first like write down the degree of freedom, which is like rho minus 1 multiplied by column. In this case, it will be equal to 6. And then you just enter the number into the matrix. Yeah, and then go to test and then do chi-square goodness of the test. And then just enter all the value and you will get the probability. And in this one, the probability is 0.0201. And since 0.0201 is less than 0.05, therefore the rejected null hypothesis.
Yay, okay. The null hypothesis is when like the what is that, the categories doesn't have a significant difference, right, from the expected values. So like the value is like as expected.
You guys understand?
I saw texting going on.
This set of data fit this type of distribution.
total. Um, 15%, so 0.15. Yeah. Hmm. Yes. Yeah, that's pretty much it. Last question. I didn't calculate it. Oh, okay. So we can assume it's from the same distribution. Okay, that's it for today. We're done. Yay. Yeah.